So in today's lesson, we're going to take a look at writing equations in Vertex factored in standard form given a graph. So we're going to start with writing the equation in Vertex form. You can see our steps off to the left. Of course, the first thing we need to know is the vertex. So I'm going to start by writing the equation of the generic equation of vertex form. So we get x minus h quantity squared plus k. So we substitute the vertex in for hk. For our graph, our vertex is 3, negative 2. So the 3 is going in for h. Remember, it's going into the asylum, so it will look negative when we put it in the equation. The negative 2 stays outside the asylum, so it stays as a negative 2. I'm going to leave the other variables alone for now, and we'll see what we're going to do with those next. Step 2, identify one other point. We're going to substitute this point in for x and y to solve for the a value. What we don't know is if this graph has been stretched or compressed. The a value will give us that information. So we put 0 in for y. We're solving for a. We know it hasn't been reflected because it opens up, so we know a will be positive. And then we simplify and solve for a. So we get 5 minus 3 is 2, squared is 4. So we have 4a minus 2, adding 2 to both sides, and dividing everything by 4. And simplifying, we get 1/2 for a. So to write our equation, we're going to go back up to that generic equation. X and y become variables again. A, h, and k should be numbers when you're done with your equation. And finally, domain and range. We're looking at domain of a quadratic function, so that will always be all real numbers. The range, because our graph opens up, it will be y is greater than or equal to the y coordinate of our vertex. So we can get that from the equation or from the graph. So y is greater than or equal to negative 2. We're going to look at one more. If you feel like you have this concept down, go ahead and move on to the next video, which will be factored form. All right, so this one, again, I'm going to write the equation of the vertex form generically so that you get used to that. The more you write it, the more you'll remember it, and then the less you'll have to look it up, for example, when you get to a quiz or a test. So I'm going to start again by figuring out what that vertex is. The vertex in this case, negative 1, 4. So that negative 1 is going in for h, and it will become opposite. The 4 is going in for k, and it will be normal. A is what we don't know, so we're going to come back to that. And the other point we have on this function is 1, 3. So I'm going to substitute 1 for x and 3 for y to solve. Simplifying inside the parentheses, 1 plus 1 gives me 2, squared is 4. Subtracting 4 from both sides. And dividing everything by 4, we get our a value of negative 1/4, which does match with our graph because it opens down. So we got a negative a value. Going back in to write the generic equation, sorry, lost my coefficient, negative 1/4, x plus 1 squared plus 4. Looking at the domain, again, quadratic function, domain is all real numbers. And the range would be y is less than or equal to, because our graph opens down, and the y coordinate of our vertex is 4.